colleagues, I'm very glad to invite you at Collins 2022 conference, and let me present our work intelligent identification system of the process liquid solutions composition offered by Oleksandr Bezsonov, Oleg Ilyunin, Oleg Rudenko, and Oleg Sotnikov. Standard task of different processes is to maintain an optimal level of concentration on individual component of working solutions. The lack of timely and objective information about the concentration changing leads to excess consumption of solutions, reducing the efficiency of equipment, and even worse, the emergency shutdown of the process. Sulfuric acid is one of the most important industrial assets with over 190 million tons production per year with annual growth about 2%. The large manufacturers of steel production generally use sulfuric acid for pickling processes. The waste product of pickling processes includes acidic water, iron sulfates, metallic salts, and waste acid. Continuous carbon steel pickling lines use the much water solution of sulfuric acid as pickling liquor. The analysis of pickling solution components in pickling baths is significantly more complicated problem what directly connected with pickled carbon steel strip quality and pickling line capacity. Existing methods and equipment of the solution composition control require additional laboratory analysis with mandatory operational personnel participation or not sufficiently versatile in regards to the solution composition. Now for measurement of salts, ultimate permissible concentration PC in the pickling solution, the direct chemical titration and non-destructive testing or non-contact methods are used. Existing analyzer provide a way to measure the overall pH in the temperature range of the solution from 5 to 80 degrees by Celsius, but don't allow to determine the concentration of some components in aggressive sulfate environment. Ferrous sulfate salts are present in three forms in pickling solution, and ones are resulted because of reaction of carbon steel strip scale and its iron part with sulfuric acid. The use of exact analytical relationship for the prediction of this process is difficult and not always correct. Sulfuric acid pickling the presence of ferrous sulfate heptahydride, ferrous SO4, and 7 molecules of water and ferrous sulfate monohydride is useful. At the metal plants of Ukraine, it uses a solution of sulfuric acid with concentration up to 20 or 24% and temperature range from 85 to 98 up degrees by Celsius. In this range, parameters of the total presence ferrous sulfate salts in pickling solution is capped by process order at 15%, and the presence of ferrous sulfates monohydrate is regulated by a limit of 4% independent of regulations of plant. So the effective control of PC of ferrous sulfate salts is very important to proper pickling process operation suggestion. Taking into account considered above, the present paper is devoted to development of low-cost intelligent identification system of the process liquid solution composition. The system is considered as one of the ways to control the concentration of ferrous salts in the pickling solution and the consumption of sulfuric acid for continuous process of pickling carbon steel. In the task of selective color segmentation, there are no reliable and fully automated methods yet. To solve them in a natural way, fuzzy soft approximation can be used. Ferrous sulfate salts in pickling liqueur are presented as free compounds with a different color. You should see this in the table 1. The dynamic process of the concentration change delta C of ferrous salts may be characterized with monotonic function, non-decreasing interval 0 to T0 and limited with the value of supreme C. If summary concentration of ferrous salts multihydrates in liquor reaches value C, the system becomes ineffective or stops it functioning abnormally. The control action for such situation is the liqueur refreshment. You can see this at figure 1. The change of concentration of multihydrate ferrous salt are drawn by a green line. To build our system, we need to form the production rule set with a minimum number. Okay, would describe a mapping of its inputs. Each rule specifies some fuzzy point in the display space defined Cartesian product x1 to x2, etc. to xn and to y in the next form. Describe it. Equations 1. A fuzzy graph in the display space is formed from a set of fuzzy points. The approach of active salt concentration C from time measurements in the pickling bath based on fuzzy estimation of this value with using the classifier is proposed. The structure of classifier is present below equation 2, where Cl class label, color of the salts in the test solution volume, x valid interval characteristic values in the red, green, blue color coordinate space, and st area of the salts in the test solution volume. R e x is a set defined of the set x of fuzzy interval estimation of y values of parameters measured in the series of n concentration measurement. Proposed intelligent identification system is implemented in the production site of control of solution parameters in the following composition: light source of constant calibrated spectrum, cuvette for a solution that is automatically washed before each measurement in determined period of time, dispensers, digital photorecorder analyzer with data channel which forms graphic image files of pickling solution in the cuvette in graphic format. The system of sulfides image identification according to color and occupied area has to analyze automatically the image and classify each pixel of the image according for object. Ferrous sulfides multihydrates group and pickling solution background color. It calculates the volumetric parts of analyzed object, where weight, parts, and the surface area per unit of volume. The system is able to analyze up to 156 images step by step, keep them in memory as a table and present with data as graphical plots for dispersion. representation of system Q is illustrated in figure 2. The surface occupied by appropriate color is calculated according to pixels with color coded number, taking into account equation 3, where V from RGB describes the membership of a pixel in the cave color cluster according to the RGB coded interval in accordance with table 1, and takes the values null or 1 in the case of clear visibility of the color class, as k is the number of pixels allocated to the cave color cluster defined by image analysis result. The classical evaluation of an object X belonging to a specified I cluster is the smallest Euclidean distance. In the equation 4, C is the coordinate of the cluster center relative to the axis OXL in space X, and XY is the coordinate of the classified object relative to the axis OXL. Simultaneously, the test iteration to measure concentration and measurement of Vk are carried out at every moment Ti. Also, a series of n reference measurements of concentration of the cave salt Ck is made by gravimetric analysis of the dry residue with satisfactory accuracy delta T. On the basis of statistical data on the state of salts in solution obtained by the method of the classification, the membership mu from Vk in time functions are formed. The membership functions mu establishes the accordance between actually measured values and value C establishing next relations. Number 5. The formation and configuration of classifier is made under the following assumptions. The cave salt is clearly related to the class on the basis of color. Are known its footprint with a relative accuracy of 1 pixel to 1 million pixel. Future digital camera fast bulb and mass, the specific volume resistance of mist in the test samples of dimensions. Measurements are taken at equal time intervals. The configuring of classifier is based on a common clustering Cummins method for one-dimensional case. The algorithm of the method is given in the article. The number of clusters in each of the L series consisting of n measurements is determined empirically according to the frequency of manifestation and by the model number of input and output values in the series of measurements. Each element of the sample of measurements is included in the closest cluster. The inclusion of elements into cluster can be done on the basis of formula 4. Later, the median of clusters in input coordinate are determined by the cumulative and taken into account all the included elements according to the formula 6. The series of n measurements forms a single cluster. The maximum close to the ith cluster is defined according to formula 4 and described by equations 7. Representation of C in the neighborhood of a point nu plus minus delta can be calculated by using Gaussian membership functions according to the formula. According to the formula 1, equations number 8. Later we determine the input and output values medians of clusters by the equations 9, and later we do the definition and parameters of clusters membership functions. It's appropriate to use exponential membership functions of the formula 9, and the corresponding Gaussian membership functions are specified as equations 12. In the absence of measurements in a neighborhood of coordinate system origin, the diamond cluster, completely excluding any element, is declared as null. The value of delta is chosen to be equal 1/3 of the distance in the input space in accordance to the 9th formula. You should see these calculations in equation 13. The exception 13 for the first cluster is transformed in the asymmetric Gaussian function in accordance with exception 14 and 15. For the dependence C from V of the resultant clustering and membership functions, output parameters are presented in article and calculated by formula 16. After definition of such dependencies for all kinds of cells from table 1 and the dependence of the form CV, we have the possibility to carry out the operational control of salt's permissible concentration and indirectly to determine the dynamic changes in the concentration of pickling solution C with the recalculation of the mass of SO4 groups in the ferron SO4 anhydrates. Within the cluster, the integrated function 16 is implemented using Gaussian membership functions by the FCM method for the classifier means, where nu E and nu E-1 are accepted as the center of neighboring classes, and the current value of nu from time obtained during the execution of process belong to the E class by the criterion of the minimum Euclidean distance from the estimated object to the center of the ith class V nu I. In addition, by introducing a time coordinate and or m additional parameters into the space of arguments, it is possible to obtain a predictive model that works in a short prediction period delta t according to the following rules 17 equation 17. The surface purity coefficient QE, which generally takes into account the area and thickness of the pickle defects and hence the mass of iron oxides that have reacted with the pickling solution, can be used as an additional parameter for constructing an artificial neural network with the indicated properties. The study points in the neighborhood of permissible concentration will provide an opportunity to synthesize near-fuzzy model. Finally, the obtained intelligent identification system may be realized as an ARM microcontroller with high-speed graphics coprocessors of the Cortex series, using the OpenCV software library for image segmentation to enhance the automation procedure. Approbation of the proposed system in combination with the pickling solution temperature control system showed the reduction of acid consumption from 1 ton 230 to 1976 kg per hour. This is due to an increase in the accuracy and frequency of measurement, time of measurement from concentration of ferrous SO4 presented on figure 1. The new system has a direct influence on the improvement of the process sustainability, safety and reliability of the reduces the operation cost, pollution and overall production expenses. Dear colleagues, thanks for your attention.